Hello viewers, welcome back once again to my channel, Math Made Easy with PDY. It's a great privilege coming your way with another lesson today. In today's episode of our lesson, we are actually going to look at quadratic functions, how to write them in the vertex form. And then also, we'll be looking at how to use the vertex form to determine the maximum and minimum values of quadratic functions. Good. So to begin with, we've learned that the standard form for every quadratic function is given as y equal to ax squared plus bx plus c. This is the standard form for every quadratic function. This function can be written in another form, which is the factor form. So you can also write it as y equal to, let's say, in one bracket x plus a, then into another bracket x plus b, or it can be minus at the same time. So that's a factor form. Then for today's lesson, we want to change the standard form and write it in the vertex form. And the vertex form is always given as y equal to a into bracket x plus, let's say, b all squared, then plus c. That is the vertex form, the vertex form. And that is a factor form. And then that is the standard form. Good. So having these three forms, we want to know how to write the standard form in the vertex form. When you are able to express any quadratic function from the standard form to the vertex form, it has a lot of importance. It helps you to determine the turning point of a quadratic curve. So to begin with, if we have our function y equal to ax squared plus bx plus c, to express it in the vertex form, there's a schematic way of going about it. Using the idea of completing of squares, then we are going to have it as y equal to a into bracket s squared plus b on a x plus c on a. That is, first we need to factorize out the coefficient of x squared to make it 1, and that is why we had it as that. And then the next step we need to consider is to make x squared plus b over ax what we call a perfect square. So how do we do that? So we still have y is equal to a into bracket x squared plus b on ax. Then we select the coefficient of x, which is b on a, half it, square it, add and subtract to the expression. So you are going to have it as plus b on 2a, then minus all squared, minus b on 2a all squared, then plus c on a. So as I said, using the idea of completing of squares, first see to it that the coefficient of x squared is 1, so you need to factorize out a from the function. So in factorizing out a, you are going to have it as a into bracket s squared plus b on ax plus c on a, because when you multiply through by a by expanding, you realize that you get the original function, which is up here. So now making the expression s squared plus b on ax a perfect square, as I said, you need to select the coefficient of x, halve that expression. So b on a divided by 2, it will be given as b on 2a. Then that expression must be squared. Then we add and subtract it to the same expression. So this is what we are going to have. So automatically, upon doing that, you are going to have x squared plus b on ax plus b on 2a all squared. The first three terms of that expression becoming a perfect square. And that will be given as, we are going to write this expression in a factor form. So that will be generated as y equal to a into a big bracket. Writing the factor for that, it is going to be x then plus b on 2a all squared. Then considering the expression here, we are going to have it as minus b squared over 4a squared plus c on a. We can regroup this and then also have it as y equal to a into a square bracket x plus b over 2a all squared, then plus c on a minus b squared over 4a squared. And we can equally merge it, so that will be given as y equal to a into a square bracket x plus b over 2a all squared, then plus the LCM is going to be 4a squared, and then a goes into 4a squared 4a times c, that will be given as 4ac, then minus b squared. So ideally, expanding through our a, we are going to have it as y equal to a into bracket x plus b over 2a all squared plus a into bracket 4ac minus b squared all over 4a squared. Then since this is in a factor form, we can do away, this a can do away with one of the a at the denominators, and that will be given as y equal to a into bracket x plus b over 2a all squared plus, this goes there, doing away with one of it, so it will be left with 4ac minus b squared over 4a. So ideally, the vectors form is what we've actually generated here. So this has become something like a formula for which you can actually use to determine the standard form of a quadratic function in the vectors form. So if you compare it to what I wrote here, it means we have y equal to a, which matches with what is up here, and then x plus b all squared goes with what is up here, and then plus our c, which goes with the expression up here, which is what is up here. So in this case, what we have here can go further to give us so many expressions. So let me copy this and then let's finalize it on a different page. So having our expression here, what it means is that having y equal to a into bracket x plus b over 2a all squared plus 4ac minus b squared over 4a, you realize that to determine the turning point of a quadratic function, you have x plus b over 2a equal to 0, and that is x equal to minus b over 2a. And this is what we call the line of symmetry, or the equation of the line of symmetry. And then also y equal to 4ac minus b squared over 4a actually becomes the corresponding y value. It becomes the corresponding y value for the turning point. So these two expressions here are very important to actually quadratic functions. You can use it to determine the turning point, and you can also use it to determine actually the maximum and minimum values. So also we say that the corresponding y value of the turning point is also known as the minimum or the maximum value. So the question may even ask you to determine the minimum or maximum value, and that's the corresponding y value for the turning point. And the s value is given as that. So I believe you've learned this as a formula to determine the line of symmetry of any quadratic function. You can use this to generate it faster without going through any stressful activity. So please take note, when you put these two x and y values together, it gives you the minimum or maximum point. So putting the x and y values together, it gives you the minimum or maximum point. So we can finally also say that the maximum or the minimum point of a quadratic function is given as minus b over 2a and then 4ac minus b squared all over 4a. So this expression here can help you to determine that. So let us take into consideration how to determine the maximum point and minimum point of a quadratic function. All this taken into consideration, you should know that every quadratic function has two main points of turning, which is the maximum or minimum. When it is maximum, we learned early on that if you have the quadratic function as y equal to as squared plus bx plus c, if it is a maximum function, then it means a is less than 0. If it is a minimum function, then a is greater than 0. So having that also in mind, it makes it very easy to determine whether the quadratic function is going to be a maximum quadratic function curve or a minimum quadratic function curve. I'll be making a new video on curve sketching in terms of quadratic function. So we'll be looking up to that, and then you learn also from that. But as I said, today we are learning how to write any quadratic function from the standard form into the vertex form. And we found out that the vertex form is given as y equal to a into bracket x plus b over 2a all squared plus 4ac minus b squared over 4a. And then the 4ac minus b squared over 4a is known as the minimum or the maximum value for the turning point. And then also we have x plus b over 2a when equated to 0, and you solve for x, it gives you what we call the line of symmetry. Good. Let's take some work example on how to use this expression to answer some questions. So I have one question here. Find the minimum value of the function. And we have the first question as y equal to x into bracket 1 plus x. We are to determine the minimum value. Now remember, as I said, before you can determine the minimum value or the maximum value is given by the expression y equal to 4ac minus b squared all over 4a. You can just use this and then you are good to go. Now, why is it saying minimum value? When we write the expression given here, in the standard form, it will be y equal to x plus x squared. And when we rearrange, it becomes y equal to s squared plus x. Therefore, the coefficient of s squared is actually 1. And that value is greater than 0. Therefore, it tells you that it's going to be a minimum value. That is why the question demanded for the minimum value and not maximum value. So since we've been able to write the question or the expression in the standard form, then we can generate our values for A, B, and C. A is actually what value? You bear with me, it is 1. B, which is the coefficient of x, is also 1. Our C is missing, so that is 0. Substituting it into this, y will be equal to 4 times 1 times 0 minus 1 all squared, all divided by 4 times 1. Simplifying, y will be equal to 4 times 1 times 0 is 0, so it will be left with negative 1 at the numerator divided by 4. So our minimum value for this question is y equal to negative 1/4, which is possible answer C. Possible answer C. Let's take another one. Find the minimum value of this. So having the function as y equal to 2x squared minus 8x plus 3. Remember, it's a minimum value for the fact that the coefficient of x squared is a positive number, and therefore it tells you it's going to be a minimum value altogether. So going straight forward, we know the expression to determine the minimum or maximum value, which is y equal to 4ac minus b squared all over 4a. And with that, from our function here, a value is 2, b value is negative 8, and c value is 3. So let's substitute. So y will be equal to 4 times 2 times 3 minus negative 8 all squared divided by 4 times 2. So y will be equal to 428. 8 times 3 is actually 24 minus 8, negative 8 all squared is 64. So we have that all divided by 8. So going further, what do we have? We are going to have a negative number as usual. So 24 minus 64 will leave an answer of negative 40 on 8. Negative 40 on 8. So negative 40 on 8 is a final answer of negative 5. Negative 5. So that is possible answer B. So it tells you that our minimum value is y equal to negative 5. There are more to this. As I said, when I start with the curve sketching, you understand how the minimum value and then the maximum value are very important when it comes to quadratic functions altogether. Then we go to another. We have the equation of the curve is y equal to that. x squared minus 6x minus 12. Find the minimum value. So it goes ahead. That's another minimum value question. I would like you to give it a try. Pause the video, give it a try, and then give me the feedback also on that. So I believe you've had an answer to the question. And how did you get it done? A value being 1, B value -6, C value -12. Substituting it into y equal to 4ac minus b squared all on 4a. We are going to have it as 4 times 1 times -12, then minus -6 squared divided by 4 times 1. So 4 times 1, which is 4, then 4 times -12, we have it as 48, negative 48, -48. Then minus -6 all squared is 36, all on 4. So we are having -48 minus 36. And what is your answer? So I believe your answer is y equal to -84 all on 4. So -84 all on 4, you should have an answer of -21. -21. Good. So we move on to the next, and the next, this time around, it says find the maximum value of the function f of x equal to that. So f of x equal to 10 plus 3x minus x squared. In order for you to know what the coefficients of s squared, x, and then c to be right, then we can write it as f of x is equal to -x squared plus 3x plus 10. Therefore, my a value is -1, b value is 3, c value is 10. And that leads me to determining the maximum. This time, maximum for the fact that the coefficient of x squared is a negative number or a number less than 0. And therefore, that is why we are having maximum value and not a minimum value. So determining the maximum value, we still use the expression y equal to 4ac minus b squared all on 4a. And that will be giving us y equal to substitution 4 times -1 times c value 10 minus 3 all squared divided by 4 times 1. Going further to simplify, y will be equal to -4 times 10, -40 minus 9 all on 4. And that will give us y equal to -49 on 4. -49 on 4. Yes, that should be the answer. Unfortunately, they have it as a positive number, but it's supposed to be -49 on 4. For that year, I believe that was a bonus mark for them. That's a bonus mark. So that is it. That is it. Going further, we have a section B type of question or a subjective type of question. It says express y equal to 5 minus 2x minus 4x squared in the form a minus b into bracket x plus c all squared. Now, per whatever we have here, it tells you that they've written the quadratic function in the vertex form. So you can use the completing of squares method to generate the answer, or you can also use the formula that has been deduced to also determine the answer to the question. There are so many ways of getting the answer. As long as you are able to tell us what the values of A, B, and C are in the expression, you are good to go. So using completing of squares, then it means you are going to have it as, I'm going to use two methods to get this answer done. So please kindly follow me carefully. The one you are okay with, please go ahead and use it. Having y equal to 5 minus 2x minus 4x squared, then we are going to rearrange so that it will be easier for us to factorize. So y will be equal to minus 4x squared minus 2x plus 5. So using the idea of completion of squares, as I said, you factorize out the coefficient of s squared, or you see to it that the coefficient of s squared is 1. But we have negative 4 there, so we have to factorize. So we are having it as y equal to negative 4 out into brackets x squared minus plus 2x on 4. Then going further, y plus 2x on 4. I will reduce it to become half. When negative 4 multiplies 2x on 4, it should give us negative 2x. That's why it became plus 2x on 4. Then we have minus 5 on 4. Then again, minus 4 multiplying minus 5 on 4, it will be left with positive 5. So that's how the factorization needs to be applied. So we need to make the expression s squared plus 2x on 4, or half, a perfect square. Let me reduce it and make it that. So y equal to minus 4 into bracket s squared plus half x, then minus 5 on 4. So going further, making s squared plus half x a perfect square, this is where you apply, taking the coefficient of x, halving it, square that value, add and subtract to the expression. So you are going to have it as y equal to minus 4 into bracket s squared plus half x, meaning I'm just repeating this. Now the operation comes in. The coefficient of x is half. When we divide half by 2, we are going to have 1 on 4. Then we square it. So we are going to have it as plus 1 on 4 all squared minus 1 on 4 all squared. Then we have our minus 5 on 4 coming on board as well. So let me make this a square bracket. Going further, the first 3 terms has become a perfect square. So we write a factor for it. So y will be equal to minus 4, square bracket comes in. Getting the factor for it, pick one factor here, x, the other plus 1 on 4, put them together and square it. When you expand x plus 1 on 4 all squared, it gives you the expression up here. Then minus 1 on 16, then minus 5 on 4. Then we close our bracket. Then further to this, we can simplify this and then expand through. So y is equal to minus 4 into bracket x plus 1/4 all squared. Now 1/16, you can use your calculator to do that so that it will be faster. Negative 1 on 16 minus 5 on 4. Now it gives us an answer of negative 21 on 16. And then now we can expand through y will be equal to the negative 4, multiplying that we have negative 4 into bracket x plus 1 on 4 all squared, then minus 4 multiplying minus 21 on 16. So that is actually going to give us an answer of, let me do away with the square bracket here because I've expanded through. So that will be leaving us a final answer of y equal to minus 4 into bracket x plus 1 on 4 all squared, and this will be plus 4 going to 16 4 times, so it will be plus 21 on 4. 21 on 4. So ideally, we've been able to express the y equal to 5 minus 2x minus 4x squared in the form a minus b into bracket x plus c all squared. We can rearrange it. So y is equal to make it easier for you to compare, 21 on 4, then minus 4 into bracket x plus 1/4 all squared. So per the question, y equal to a minus b into bracket x plus c all squared. Then it tells you that a value is actually 21 on 4, b value is also 4, and then c value is 1/4. C value is 1/4. So my dear students, it looks so lengthy though, but it's worth it. As long as it's question 9C, you are getting all your marks as expected, it's worth doing this. Remember, this is the completing of squares method. That's the completing of squares method. You can also use another method to get the same answer, which is you expand and simplify, then you compare. Expand, simplify, and compare. Now, the other part of the question was, hence state the maximum value. Remember, this question is maximum for the fact that the coefficient of x squared is a negative number. So that is why it's demanding for maximum value. So remember what our maximum value is. We use a particular formula, but since we've gone through this method, there's no need of going to quote again, but you can go straight ahead and tell us what the maximum value is. The maximum value per this is supposed to be the a value. So the maximum value is y equal to 21 on 4. Y equal to 21 on 4. If you have any problem with the expansion and simplification, you can just leave a message and then I'll just attend to that. So please practice, and then I believe you are going to be fine. Let's take another example. There are so many ways they ask questions on this, so let's take another example. Express 7 minus 5x minus 2x squared in the form that, and state the greatest value. As I said, there are other ways of doing it, so let me use the other method to get it done. So with the other method, you just have to expand the given expression, simplify, and compare with the given function. So if we have the given function as y equal to 7 minus 5x minus 2x squared, then we can also say that then y should be the same as a minus b into bracket x plus c all squared. So expanding that, we're going to have it as y equal to a minus b into bracket. This expansion gives us x squared plus 2xc plus c squared before you can multiply the b through. So we're going to have it as y equal to a minus bx squared minus 2bcx then minus bc squared. And this must be compared to the given function. This must be compared to the given function. So what I mean is that we have it as the given function as 7 minus 5x minus 2x squared. It should be the same as a minus bx squared minus 2bcx minus bc squared. Yes, it should be the same. So we are going to compare. But before we compare, let's regroup in such a way that it matches with the left-hand side of the equation. So we have 7 minus 5x minus 2x squared. Regrouping this, it will be a minus bc squared, then minus 2bcx, then minus bx squared. This will be easier for us to compare. So comparing, it means that my a value from here, sorry, a minus, let me correct it. So a minus bc squared, a minus bc squared is equivalent to the number 7 because that's the value without any x variable. Then that is one equation. Let's say equation 1. Then we have minus 2bc, which is the coefficient of x, also being equivalent to the expression minus 5. Then that is equation 2. Finally, we can say that the coefficient of x squared, which is minus b, is equivalent to the number negative 2 here, which is equation number 3. So you need to solve these 3 equations simultaneously to generate your answers. Now, we already have minus b equal to negative 2, which is the equation with only one variable. So solving for b from equation number 3, it implies that b is going to be 2. Now, knowing what b value is, we can substitute it into the expression equation 2 and then get the c value. So substitute b into equation number 2. So we are going to have it as minus 2, b value as we've seen is 2, then times c, and that should be equal to negative 5. So that will be giving us negative 4c equal to negative 5. And that will be c dividing both sides by negative 4, negative 5 on negative 4, which is finally c is 5 on 4. Then having b and c known, we can solve for a from equation 1. So from substitute b and c into equation 1. So that will be giving us a minus b value, as we said, is 2 multiplying c value all squared. C value is 5 on 4 all squared, and that should be equal to 7. So a will be equal to 7 minus. Now, when we simplify this, you can program it on the calculator to make it faster for you. You're going to have it, it's supposed to be plus. You'll be having it as 2 multiplying 5 on 4 all squared. So 5 on 4 all squared. It will give us a final answer of 25 on 8. So we have it as plus 25 on 8. Then now you add this to A will be equal to 25 on 8 plus 7. It will give us an answer of 81 on 8. 81 on 8. So then it means we have to write it. It says express the function here in the form of that. So you just have to bring it back. You just have to bring it back, and then that will be giving us. It implies that A is 81 on 8 minus B value, which is 2, into brackets X plus C value. We saw that C value was 5 on 4 all squared. So that is the form for which the question needed us to write the function. As I said, there's another method you can use to get the same answer. It leads you to simultaneous equation, and then you have to generate your answers and write your final answer. Now, the second part of the question says state the greatest value. Being able to write it in the Vertex form, the greatest value, you can just state it. The greatest value, the greatest value is the same as the maximum value. The greatest value is y equal to 81 on 8. It means when you sketch the curve for this, it will be turning at y value of 81 on 8. That's what it means. That's what it means. Now we go to another example, which is if 2x squared minus x minus 3 is equal to that, find the values of a, b, and c, hence the minimum value. So you can use any of the methods that I've shown early on, and then I believe you are going to be fine with that. Then again, you have another one here. Perhaps let me do the last one here, and then we call it a day. So having h of s equal to this and h of s equal to that, we just have to write it. This is the Vertex form of it. We should use this information to determine what the value of P is and also find the value of Q plus R. You can use any of the methods, and I know you are going to get the same answers. So to use the completing of squares approach, then we are going to have h of x equal to 3 into brackets s squared minus 7 on 3 x plus 2 on 3. Perhaps I'll use the two methods to generate the same answer. Then now you see that it's the same. You just have to apply both and you'll be okay. Practice it and you'll be fine. Then we are going to make the s squared minus 7 on 3x a perfect square. So that will be giving us a square bracket s squared minus 7 on 3x. Half of negative 7 on 3 is going to give us negative 7 on 6. Then we square it. Then we add it and subtract. So plus negative 7 on 6 all squared minus negative 7 on 3 all squared. Then we continue plus 2 on 3. Close the square bracket. Automatically, the first 3 terms in the function of the function in the bracket has become a perfect square. So, sorry, here is 6. So we are going to have it as 3 square brackets open. Then we write a factor for that. That is x minus 7 on 6 all squared. Then we merge this. This will be giving us minus 49 on 36 plus 2 on 3. Merging the two, 3 square bracket open, x minus 7 on 6 all squared. Now using the calculator to get it done, negative 49 on 36 plus 2 on 3 plus 2 on 3 gives us an answer of negative 25 on 36. So it gives us minus 25 on 36. So finally, we can expand through. So you have it as 3 into bracket x minus 7 on 6 all squared. Then minus 3 into bracket 25 on 36. Then you have it as h of x is equal to 3 into bracket x minus 7 on 6 all squared. Then when negative 3 multiplies, it will go into 36 how many times? So you have it as 36 divided by 3, that is 12. So you are going to have it as minus 25 on 12. Minus 25 on 12. So we've been able to write it h of x equal to p into bracket x minus q all squared, then plus r. When we compare, it means our p value is equal to 3. Our q value will be equal to 7 on 6. Why is it 7 on 6? It's not negative 7 on 6 for the fact that both of them are negative, so it's supposed to be a positive number. Then our r value will be equal to negative 25 on 12. Negative 25 on 12. So we've seen our p, q, and r values. So I asked for p value, which is 3. I asked of q plus r. So that is going to be 7 on 6 plus negative 25 on 12. So you can just use your calculator to get your final answers. 7 on 6 plus negative 25 on 12. That will lead us to an answer of negative 11 on 12. Negative 11 on 12. Since this is our final question for this lesson, let me use the other method to get the same answers as I said. And so let me just copy this question here. And then I send it to another page. Then I'll do the same thing. Another page. So let's look at it using the other method, which is the expansion and simplification method. So what it means is that my h of x, which is equal to p into bracket x minus q all squared plus r. When we expand this, we're going to get p into bracket s squared minus 2xq and then plus q squared, then plus r. Going further to expand, we have px squared minus 2xpq plus pq squared, then plus r. So we need to compare this with the original function, which is h of x, which is equal to 3x squared minus 7x plus 2. So comparing, the coefficient of s squared, which is p, is equal to 3 over here. 3. Then the coefficient of x is going to be negative. So this is equation 1. Then coefficient of x is negative 2pq must be equal to negative 7. That's equation 2. Then equation 3 is going to be the true constant. So pq squared plus r should be equal to 2. That's equation 3. So since we know the p-value, we can substitute the p-value into equation 2 to get q-value. So substitute p into equation 2. So we'll be having it as negative 2 into brackets 3, then times q should be equal to negative 7. That will give me negative 6q should be equal to negative 7. So dividing both sides by negative 6q will be equal to negative 7 on negative 6, which is finally q as 7 on 6. Then having p and q known, I can find r. How then do I find r? From equation 3, substitute p and q into equation 3, and that will be p value is 3 multiplying q value, which is 7 on 6 all squared, plus r should be equal to 2. So r will be equal to 2 minus, now when you simplify that, it will be 3 into brackets 49 on 36. And as you know, r will be then 2 minus 3 will go into 36, which is 12 times. So we have negative 49 on 12. So r value will finally be 2 minus 49 on 12. From the calculator, you have an answer of negative 25 on 12. So that is the second method that I said you can also use to generate the same answer. That's the second method you can use to generate the same answer. Let's compare whether the answers are the same. When you go to the previous page, yes, our p value was 3, q value was 7 on 6, and then r value was is negative 25 on 12. And that's the same answers we are getting over here. So my dear students, I'll be very glad if you practice as many work examples on this concept of quadratic function, how to write it in a Vertex form, and also how to use it to determine the maximum and minimum values of the quadratic function. Please remember that when you are asked to write the expression in the form h of x, that is in the Vertex form, please be mindful of how you go about it. If you know the formula, you can go straight ahead and use the formula and substitute to get your answers. If not, please use any of these two methods, and I believe you get it right. Thank you so much for joining the lesson. I'll be coming another way for a new lesson on this, so please stay glued and then share my lessons with your friends. Tell them also to subscribe to my channel to help my channel grow bigger. Together, let's all make math easy to study. Thank you and have a nice day. God bless you. Bye.